All right, we are going to look at basically how to transform some graphs, okay? So first of all, we're going to look at ways that we can take equations and we can shift graphs left or right and up and down, okay? So if you have something added on inside the parentheses, it will, or subtracted, it will move it left or right. If you have something added on at the end of the function, it would move it up or down. So we'll just kind of do some examples of this, and I think that you will um, see how this works. Okay, so first of all, it's saying describe how the graph of the absolute value of x can be transformed. So first of all, if you don't remember, the graph for the absolute value of x looks like this. Okay, when I add or subtract a number on the end, it moves it up or down. So if it's a negative, it moves it down. If it's a positive, it moves it up. So this graph is going to go down 4. I'm not expecting you to take time to put this onto your calculators, but if you did, it would go down 4 units and it would end up looking something like that. Okay. And you can see that I graphed it right here. The difference between that and this one is now what you've added and subtracted is inside the actual function. So, and it's actually opposite of what you think. If it's a plus sign right here, it actually goes left. So this graph is going to go left 2 units. Okay. If it was a minus sign in there, it would go to the right, but it's left. It's an addition, so it will go left. So it will look something like that. The red dotted line is the original, and then when it moves left 2, it becomes the blue line. Okay, and here's a few more. So we started with the x cubed function, which is the red dotted line. And hopefully you can see that this one moved that x cubed function down 3. So that would change the equation to x cubed minus 3. Okay. This one moved the x cubed function left 2. So that would change the equation to x plus 2 cubed. It has to be added on inside. And this one moved it right 3, which changes it to x minus 3 cubed. Okay, so that's how things, how the equations work when you move them right, left, up, or down. Okay. Then we're going to look at flipping them both either across the x-axis or the y-axis and see what you have to do with your equations here. When you want to flip them across the x-axis, then you take the entire function and change the sign on everything. If you want to flip them across the y-axis, you change each individual x only, okay? And so hopefully you'll see the difference. All right, so first of all, I want to do this across the x-axis. So to flip it across the x-axis, I take a negative in front of the entire function. So I take the negative and I distribute it to the function. Some people think in this case that you would distribute the negative to the top and to the bottom. If you distribute it to the top and the bottom, that's like having a negative over a negative, which turns positive, and that doesn't work. So just distribute it through the top, and it becomes negative 5x plus 9 over x squared plus 3. Okay, or you might want to write it 9 minus 5x. It's the same thing if you have 9 minus 5x on the top, just so you know. Okay, if we want to flip it across the y-axis, then we take each individual x and change its sign. So it would become this, 5 times negative x minus 9 over negative x squared plus 3. Well, 5 times negative x is negative 5x minus 9. On the bottom, when you take a negative x and you square it, taking a negative and squaring it is going to make it positive, so it just becomes x squared plus 3. Okay? All right, and then we want to look at stretches and shrinks. So if we take the individual x and we divide it by a number that's bigger than 1, it will stretch it vertically. So it will make the top be taller and the bottom be shorter, or stretch it like, stretch it vertically, okay? If we divide that by a number that's smaller than 1, it will shrink it. Okay, and that's horizontally, and then vertically would be if we multiply it, the whole entire function by a number. Okay, so we'll do this, and I think you'll see what happens. All right. So it tells us that I'm going to use this function right here, which is x cubed plus 3x, okay? And in part A, I want to do a vertical stretch of that function by a factor of 4, okay? So when you do vertical stretches or shrinks, you just take whatever you're stretching or shrinking it by and multiply it by the entire function, okay? So this is a vertical one. So I want to stretch it by a factor of 4, which means I'm going to take 4 times C1, which in this case is 4 times x cubed plus 3x, which then I can distribute that through, and it'll be 4x cubed plus 12x. Okay. If I want to do a horizontal shrink of 1/2, so what you do for horizontals is you take each individual x value and you divide it by whatever factor you're using. Okay, so in this case, I want to take that x, I want to shrink it by 1/2, which actually ends up, you'll see. Okay, that's what happens. I take each individual x and I divide it by that quantity. Okay, now x divided by 1/2, just so you know, is the same, like instead of dividing by that fraction, I can multiply by its reciprocal. And so that's the same as taking 2x and cubing it. Okay, and then when you take 2x and cube it, you get 8x cubed, and then plus 6x here. Okay. And then we're going to do a couple more where we kind of put some of these results together. So I am starting with a basic function right here of y equals x squared, and I'm going to do some things to it, and I want to see what happens to my function. So first of all, I'm going to shift it to the left 5 units. When I shift it to the left, I need a plus 5 in there, added on inside the parentheses. Then I'm going to vertically stretch it by a factor of 3. That means I need to put a 3 in front of the whole equation. Okay. And then I need to do a vertical translation. That means I need to move it 4 units up. So I will add a 4 on to the end of the equation. And it should look something like that. All right, then in this next case, I'm giving you a function. It's just f of x that's graphed right here. And then I did some things to the equation, and I want to see what happens to the graph. So this one, if you have a negative in front, we'll flip it over the x-axis. This will move it right 2. And this will move it up 4. Okay, so I have this graphed for us stage by stage so that we can kind of see this. So I started with the original function. I moved it right 2 in this particular graph right here. Then I flipped it over the x-axis right here. And then I moved the entire graph up 4 right here. So this would be the final graph of that whole entire function with all of its transformations done to it. All right, and we have one last one that we are going to look at here, and we are going to graph this by hand and kind of see what happens. Okay, so this means that it's a vertical stretch of 2. This means that it's going to move left 1. And this means it's going to move down 3. Okay, so we're going to kind of figure out how this goes. Okay, So the first thing I'm going to do is I'm going to stretch it by 2. What that means is that your high points become higher and your low points become lower. It does not change your x values at all. It only changes your y values. All your y values on your graph become twice as high as they were. So like this is the point -2, 0. Well, my y value of 0 is going to be twice as high. Well, guess what? Twice 0 is 0. Okay. Here is the point 0.02. My y values become twice as high. So instead of 0.2, it's becomes 0 twice of 2 or 0.4. So that point ends up going up here. Okay. So basically this curve is going to look something like that. Okay. It got stretched vertically. So that's where I'm at. Now I need to take that graph and I'm going to move it left 1. So everything goes left 1. So instead of being at -2, 0, I'm going to be at -3, 0. Instead of being at 0.4, I'm going to be at 0.4, I'm going to be at -1.4. Instead of being at 4.0, I'm going to be at 3.0. So now my graph looks something like this. And then I move the whole thing down 3. Okay. So hopefully you can figure out that it's going to go something like this. Okay, and that would be the final graph for that function. And you know what? We are going to skip these absolute value things. We aren't going to worry about them. And that is going to be it for this lesson.